All right, so hopefully we should do part 1 today, part 2 tomorrow, because I'm being realistic, we're not gonna be able to do it all in 30 minutes, so real zeros of polynomial functions. Our goal for 4.4 is to understand the factor theorem, to factor high degree polynomials, to analyze polynomials with multiple zeros, solve higher degree polynomial equations, and understand the rational zeros test. And 4.4, real zeros of polynomials. All right, so here is our polynomial factor theorem. So the polynomial factor theorem basically is stating that if given the graph of a polynomial, when you find all the zeros of the polynomial, those zeros represent the factors of the polynomial. So if you look right here, we have -7, 0, 2, 0, and 11, 0. So if you have the zeros, then you can write it in factored form. So then the factors therefore are x plus 7, x minus 7, and x minus 11. Your factors and your roots, your zeros, are always opposite of each other. So if it's -7, then your factor is going to be x plus 7. If it's +2, then your factor is going to be x minus 2. So when you write it, now you have your factored form. So this is your factored, and this is your polynomial form. Okay, and this works vice versa. If you have your factored form, then you know your zeros. So again, that's the factor theorem, basically. Questions about it so far? All right, let's dive into an example. So our first example here, we have this polynomial graph, and we want to use the graph and the factor theorem to list the factors. So the first thing I'm going to do is identify my zeros. So you're going to identify your zeros. So my zeros are at -1, 0. Agreed? That's a root. We're at 1, 0, and we're at 2, 0. Question about identifying your zeros, your roots. Remember, those words are interchangeable. Second, then you're going to write the factors. And your factors are opposite of the roots. Because that's the only way that a number can equal 0 is if you add it to its opposite, right? So looking at this, instead of -1, it's going to be +1. Instead of +1, it's going to be -1. And instead of +2, it's going to be -2. So therefore, the factored form would be x plus 1, x minus 1, and x minus 2. What are your questions, comments, concerns so far? No? Okay, I can't remember if I dive into finding A yet or if we find A next.
Why are we finding this?
Because you want to make sure that it's the exact width and range that it's supposed to be. So you have to find your stretch and shrink factor. I want to make sure if I did it now or later. Okay. So then now we're going to find, we did it in here. So we found our factors. Now we're going to find our A variable. Okay, your A variable, it's saying, how do you know how much you stretch, shrink, if you reflect it or whatever? So to find our A variable, you're going to choose any point. I say choose the lowest point possible. So you're going to choose a point that's on the graph. So looking at this graph, the best point to choose would be my intercept right here, right? At 0, -2. When I choose that point, I'm going to plug it into the function. So I know that x is 0 and f of x is -2. So we have -2 equals a is our stretch or shrink factor. X plus 1 times x minus 1 times x minus 2. But for each one of these x's, I'm going to plug in 0. Because what did we say x was going to equal? 0. So this is 0, 0, and 0. So that leaves me with -2 equals a times 1 times -1 times -2. What is 1 times -1 times -2? +2. So you have,
How is that screen blurry? If it's on the board.
what happened? Oh. Oh, it's the internet when it lags. Oh. I'm sorry. I was like, what happened? I was looking at my computer, so I didn't see what that did. All right, so what does A have to be? Oh,
I got you.
what does A have to be in order for?
0.
No,
-1.
-1. So your A equals
Where you been at, bro?
-1.
What do you mean? I haven't seen you in a while. No, like you were there, but like, oh.
Okay, so that means that your function, your exact function that fits this model, it's f of x equals. All right, so I just want to, guys, I just want to kind of recoup here. Right here, I should have put the A and I didn't, so there should be an A there. But now we know the value of A. And what is the value of A? -1. So the function for this is -1 x plus 1 times x minus 1 times x minus 2. And so if I was to graph this, I would reproduce that same graph. Why does A equal what? If I divide by 2, what happens? You get -1. Yes. Not right now.
Oh, not right now. Shouldn't take.
All right. Okay, what are your questions about it? So there's 3 steps. Step 1 is identify your zeros and roots. Step 2 is to write your factors, and they're the opposite of your roots. Step 3 is to find your A variable. You choose any point on the graph, preferably one with small points, preferably your y-intercept generally, because therefore you can use 0, right? Anytime you can use 0, it makes your math way easier. I would encourage you to use the y-intercept. And then once you find your A, then you can write your function. And those are the 3 steps that you do every single time when given a graph. Questions? All right, another type of question that comes from this is write the complete factorization. So when it's asking you to write the complete factorization of this, it's wanting you to put it in factored form given what your zeros are. So here, the first thing you want to do is probably, would you want to multiply by 2 or would you want to divide out to 7? Question.
Are you asking yourself or
Myself. We would divide out to 7 just to make it easier. All right, so here, you're just factoring. So you remember our skills, our chapter 3 on factoring. And so with factoring, you look here and you're like, okay, well, this is a lot of numbers, but these numbers all have something in common. They have, they're all multiples of 7. So I can divide out 7 and make these numbers just a little bit smaller, right? So if I do that, so I divide everything by 7, including this double decker here. When I divide everything by 7, I'm left with 7. And I have x squared minus what's 63 divided by 7. Well, 63 halves divided by 7. How do you do that? So we do 63 halves. You keep, change, flip. So it becomes 1/7. This reduces to 9, right? And that's why you have 9 halves. Yes. So when we said 9, we all understood why? All right. And then we're left with 2. All right. So then now we're down to this. And they told us our zeros already. Boom, boom, boom. The only reason why we needed to factor was because this, our GCF, that's our A. So that led us to our A. And they already told us our factors. So we don't need to do anything else except we just needed this guy, that's 7. So this equals 7. And what are our factors? Positive half. So our 0. X minus 1 half. And then x minus 4. All we need to do was figure out the GCF. That was our key. Anytime they give us zeros, we already have the factor. We just need to find our A. So they gave us our zeros. We just needed to find our A. Okay. Now, this is acceptable if I'm grading. If your Pearson is grading, sometimes they do not accept fractions as factors. And so all this is all you're doing when you have a fraction as a factor. That's such a weird thing to say, fraction as a factor. I can't remember the little cutesy way of saying it that another teacher says it, but basically you're taking the denominator and you're moving it. So then it becomes 7, 2x minus 1 times x minus 4. What is it? Bottoms up? Is it something like that? It's like a little cute way of saying bottoms up. I think it's bottoms up. So like when you have a fraction as a factor, it's just remember bottoms up. So you move the bottom to the, as your leading coefficient. And now your Pearson will accept it because do you have a fraction as your factor now? No. It's just the algorithm, the coding in it. Sometimes it doesn't allow for a fraction or as a factor. That's why I'm telling you that I will be fine here. Jones, yay. Pearson prefers that. I wrote a smiley face, but it didn't. Oh, I thought I wrote Pearson. I was like, I thought I wrote Pearson. Pearson. There we go. All right.
I said June 1st.
Oh. No. All right. So now we're gonna do this again. So again, I have the factors, right? And I know I have enough because the degree here is 3. And how many factors do I have it? 3. So I have my factors. All I need is my what? My A, which is going to be my leading term, my GCF. So I'm going to divide each one of these by what? 5. So I'm dividing by 5, dividing by 5, dividing by 5, dividing by 5. And I'm left with 5 times x cubed minus x squared minus 4x plus 4. So the GCF is my what again? Yes, but it also is my what for when I'm factoring. That's my A. So I have my A, I have my zeros. So what is my function in factor 4? 5. Say it again. X plus 2. X minus 1. And x minus 2. Now, if you wanted to, could you go through and do traditional factoring?
Yeah.
But why would you do that if they already gave you your zeros? That's what the factor theorem is there to remind you. If you have your zeros, do you need to fully factor? Mm-mm. Use your zeros. Let them be your friend.
I don't know my friends.
Okay, well, go ahead and factor. All right. So we're gonna do another one. We're gonna go back to the graph. So looking here, would you want to factor that? Or would you just rather find your zeros?
Find zeros.
You'd rather just find your zeros, right? So the first thing we're gonna do is find our zeros using the graph. So what are your zeros on the graph?
-1, -1.
So we have -1,
0, -1.
we have 1 and 0, and we have 2 and 0, right? Found our zeros. So all I need from here is to know what is the A. And your A, based on what we've been doing, has always been your what? Your leading coefficient, right? So at this point, I now know that A is the leading coefficient, which is -1/2. So we have our leading coefficient. We had our zeros. Now can I write my function? Yes. So my function is always f of x equals my A. And what is my A? -1/2 times my factors. And what are my factors? X plus 1, x minus 1, and x minus 2. And that's the function. Versus you having to multiply everything by 2 and then do grouping. And then after you do grouping, then breaking down the factors and then doing the quadratic formula. If you use the factoring rule and utilize the graph with your roots, wham bam, it's fully factored. Okay, so our first 3 examples, they've given us all the zeros. What happens if they don't give us all of our zeros? Then we have to find them, right? We have to be the ones to find them. So example 4 is an example of where they only gave us 1 0. Okay, could you use your previous knowledge of factoring and just factor this as is? Yes, you could. Would I stop you? No, I would not. So could you? Yeah, go for it. Do your grouping, do your quadratic formula, get your answers, okay? But we're gonna go through what this unit is about, which is utilizing your zeros, okay? So it tells us our 0. It gave us that one of our 0 is 1. When you're given a 0, you're gonna use synthetic division.
Yeah, I love something. Oh.
Wow. I'm so glad for you. We're gonna use synthetic division to find, to make this a quadratic. So synthetic's goal is to create this into a quadratic for us.
You know, I was talking to my aunt yesterday because she teaches algebra, and they're doing the same thing as us.
Oh, cool.
And we're basically comparing them.
So we have 1. So we have -2, -6, 2, and 6. Now we're going to bring down our -2. Please let me know if I'm going too fast. I'm assuming that we're comfortable with synthetic, so that's why I'm going to go. All right. 1 times -2 is -6 and -2 make. 1 and -8 makes. 2 and -8 makes. And 1 and -6 makes. And 6 and -6 makes 0. So therefore, I'm now left with the quadratic of -2x squared minus 8x minus 6. Okay, so you're left here and you're going to factor the quadratic. You either can factor the quadratic or you can use quadratic formula. I am more comfortable with factoring it because it's not a hard thing to factor. The GCF here is -2. That leaves me with x squared plus 4x plus 3. So it multiplies to give me 3, but adds to give me 4. Multiplies to give me 3, but adds to give me 4. 3 and 1, right? So my factors are x plus 1 and x plus 3. So step 3 is to put it all together. Exactly. So we already knew our a. What was our a? -2. So f of x equals -2. The first 0 they gave us was 1. So what is its factor? -1. And then what were the factors we got from our work? We got the factors already. X plus 1 and x plus 3. So there's our function. Yep, it's already set in this form. So we put it all together. We put the factor that was given to us, and then we put the ones that we found. Was it terrible?
No.
So again, examples 1, 2, and 3, they gave us all of our factors. But on example 4, we had to find the other missing ones. All right, questions, comments, concerns? Okay, we're just moving on through. What time is it? Okay, I think we could do one more example. So we're gonna do a real world example. It says an insect population P in 1,000 years per acre, X days past May 31st is approximated by P equals 2x cubed minus 18x squared plus 46x, where X is between 0 and 6. Determine the dates when the insect population equal 30,000 per acre. Okay, so we're looking for when does this equal 30,000 per acre? So we're looking for when does P of X equal 30? So we're taking this and setting it equal to 2x cubed minus 18x squared plus 46x. Yes. So if I write plus 0, just to fill it in.
No.
But we need to get this side equal to 0. So what do I need to do to the 30? So we're going to subtract 30, which means that we're working with 2x cubed minus 18x squared plus 46x minus 30. And we're looking for the days where this is. So we need to factor this. We can do grouping. We can do a few things. I would probably do grouping. But as long as I know one, then I can find the other. We can graph and look at the what? The zeros. We can graph and look at the zeros. We have all these options now, right? And it's just more of which one do you feel comfortable with? Do you feel comfortable with graphing and looking at the zeros and then being able to state your factors? Do you feel okay with grouping? I personally am okay with factoring. So I would probably go ahead and divide everybody by 2. And when I divide everyone by 2, I'm left with x cubed minus 9x squared plus 23 minus 30. That's right. I don't know where I got my number from. Just making sure you're paying attention. Just making sure you're alert. All right. So then now I'm here and I'm like, okay, well, what else can I do? I can make it smaller. I can make anything. At this point, I don't see anything I can factor this with, but what can I do? To the calculator. we're gonna look for our what? Our x's, our zeros, right? So I'm gonna open this guy. And I'm gonna put in x cubed, x to the third, minus 9x squared plus 23. Where's my x? X minus 15. And what am I specifically looking for on this graph? Zeros, right? Looking for my zeros. So I hit graph. Do, 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 do. Oh, look at that. Okay. It only tells me I only want to look between what x values? 0 and 6, right? So I'm going to change my window so that my minimum x is 0. And I'm going to put 7, not 6, just so I can have a little wiggle room. And bam, can I clearly see where it crosses the x-axis? Do you see them?
Yes.
Pew, pew, pew. If you do not see them, you can press second, trace, and there's the option to find your zeros. For each 0, you have to do this. So you start from the left of the graph. This little spider, he doesn't crawl very fast. All right, I'm gonna start from the left, work my way to the right, hit enter. And just in case I couldn't count, am I at 1? Yes. Just if I was unsure, I could let the spider tell me, but we clearly could see it, right? So my points here are at 1, 3, and 5. Yes? Anyone not see 1, 3, and 5? Cool. So therefore, when I write this as a factor, we have f of x equals 2 times x minus 1, x minus 3, and x minus 5. So it says determine the dates when this occurred. So it occurred on the 1st. So 1 day passed. So what's 1 day past May 31st?
June 1st.
June 1st. Okay, then it occurred 3 days past. What is 3 days past May 31st? And then we got 5, right? And then what's 5 days past? June 5th. So it said determine the dates when they would equal 30,000 per acre. These are the dates where there'll be a whole lot of bugs.
I just sent the